All right. Hello, everyone. I'm Bernd, and today is day 18 of Advent of Code. So today was a bit of an easier puzzle. Let's have a look at it. So as an input today, we give them a list of positions, and the positions are like three-dimensional space, and together they form a structure. And for the first part of the puzzle, we just have to figure out the surface area of this structure. So let's have a look at the code. To solve this, obviously, we need to read the file and split into lines. And then we will want to get the cubes from those lines. So we just iterate through lines and convert the values into integers. And then what also will be helpful is to get the neighbors of a position. So the direction will be like 1, 0, 0 and 0, 1, 0 and so on. And then we just, for each direction, we either add it or subtract that direction to the position. And then with this, we build up the list of neighbors. So both the plus the direction and minus direction. So we have 6 neighbors. And you can use that to solve the problems. So first we will get all the cubes. And then the surface area will start with 0. And then we iterate for all the cubes. And then we look at all the neighbor positions for each cube. If the neighbor is not in the cubes, or if the neighbor is not part of the structure, then that will increase the surface area by 1. For this, we can run a little test, and that looks good. So we also run it on the proper input, and that turns out to give us the right solution. Part 2 is a little bit different. So there's an interior and an exterior surface, and we'll distinguish between those two. So for example, here in 2D, we'll have the outside area and the corresponding exterior surface, and we have air trapped inside the structure, and we'll have an interior surface. So for the first part, we just calculated the sum of both. For the second part, we only want to consider the exterior surface. So for that, we want to get the outside positions. So we just put a box around our structure and then take all the positions in this box which are outside the surface, are outside the structure. And how do we get those? So we need the coordinates of the box. So we will have all the max coordinates in all this direction, all the min coordinates. Then we'll have one starting point, which is definitely outside the structure. So we can just take the minimal coordinates and subtract one more from it, and that will definitely be outside the structure. And then in each iteration, we just look at the neighbors of that point and add that to the outside area iteratively, and so this will give us all the positions outside eventually. So in code, we'll have only the starting point in the queue, and then while there's elements in the queue, we take one of the positions out of the queue, and then we'll check a few things. So for example, if the position is in the cube, so in the structure, we don't want to continue, or we want to continue and look at the next element, so that will definitely not be a part of the outside. If the position is already in the set of outside positions, we also want to continue because we already processed that particular position. And then finally, if the position is outside our box, so if either one coordinate is too small or one coordinate is too large, we'll also continue and not further consider this position. Otherwise, the position will be part of the outside positions. So we add it to the corresponding set. And then for all the neighbors of the position, we'll add the neighbor to the queue in order to process it later. Okay. So if this, we can solve the problem. So we'll get all the cubes, we'll get all the outside area, and then again, we'll iteratively calculate the exterior surface area this time. So we go through all the cubes, and then we go through all the neighbor positions. If the neighbor position is in this set of outside positions, then that will create a surface area, and it will create an exterior surface area in particular. So we'll increment that value, and then we can return it. We can also run a little test to see whether that code makes sense. And that looks good. So we can also run it on the proper input. And yeah, that's it for day 18. I hope you enjoyed today's puzzle. Best of luck for the future, and I'll see you around.